Okay, sir. Just now we will start with the identity change. Just we will change our identity. We have to write affirmation. I will show that affirmation. Okay, sir. This affirmation, just spend 30 seconds. Just write it, sir. First of all, thanks to all because today is Sunday. Spend the time you are spending the time for learning. Thank you very much, Rajesh sir, Amul sir, Rahul, Hemnath, Aditya, Nagaraj. Okay, just appreciate yourself because you take one step now yourself. Yes, sir. Your voice not clear, sir. Unmute, sir. Amul sir.
Yeah, it's not only Sunday, it is Ugadi as well as Gudi Padwa today also. It's big festival, big festival.
Big festival. Okay, sir. Okay, sir.
Yeah.
We
So
are
for
learning
Maharashtrian and Telugu people, they are celebrating as a Ugadi and Gudi
Ugadi.
Padwa. So year start with this day. So we
This,
believe
yes. Okay, we
this
will
is a
start with
special
this.
day for us and happy learning to all.
Yes, yeah, everyone. Oh, everyone. Thank you very much, sir. Okay, sir. Today we are going to start with the remaining 23rd paper, simple calculation. I will explain detailedly this chapter, this old paper. I will explain. 23rd, 24th, I will explain deeply. You no need to go through any paper chapter because I will explain everything detailedly, all the formula with the diagram, everything. Then after any doubt, you can go through this video also. Enough. Then after remaining paper, we can continue quickly. I will make the structure same repeated. You can do the old assignment like this. You going on every day. Okay, I will share the paper, sir.
Sir, every Sunday we used to do the previous question papers. Is that right?
Yes, yes, sir.
Okay. And
We
remaining
have
days the actual subject.
access subject, sir. We have to complete it parallelly. We have to do this one.
Great, sir.
Okay, this is a 23rd paper, L2-A. This is a 5 mark, 6 mark question. A ventilation duct 0.6 meter into 0.6 meter size. Average velocity in a air measured by anemometer. Anemometer is very important 1 mark. How to measure the velocity? Which meter using? This is a anemometer 1 mark.
Meter.
30 meter per second. The static pressure at inlet fan minus 25 mm WC. At the outlet 35 mm WC. mm water coolant. 3-phase induction motor coupled with the fan through the belt drive system that getting 90 ampere at 410 voltage. Power factor 0.8. Find out the efficiency of the fan. Very important. Find out the efficiency of fan. Assume motor efficiency 90%. Belt transmission efficiency 98%. Density correction can be neglected. What is the mean of density? Correction factor, no need to consider this one. First, we have to draw the diagram clearly. This is a duct. Here is a fan available. This is a fan. We are taking from here. Okay. This is a fan, FAN, fan. What is the data? The air measured when anemometer 30 meter per second. Here velocity, how much? Velocity 30 meter per second. Velocity. The static pressure inlet. This is inlet, static pressure. Where is measuring static pressure? Any idea? Always bottom side. So static pressure. Here is a static pressure. How much? Minus 25 mm water coolant. What is outlet? Fan outlet. The vessel like this only. 35 mm WC. Okay. The three-phase motor coupled with the fan through the belt drive. Okay, this the fan. This is a fan. Na? This is coupling with motor. So I draw like this. The system. It's a belt. This is a motor. This is a belt. This is a motor. Power input is how much drawing here? It's a power in. Power in we have to find out. Voltage, how much? 415 voltage. Ampere is a drawing, power drawing. I, load current, 19 ampere. What is the power factor? 0.8.
Voltage 410, no?
Wait, sir.
Voltage
Okay, sir. Yes. Thank you, sir. 410. 410. Oh, very important data. Once you write in, 2 times we have to check it. Cross check. Very important. Once writing, you have to cross check. Assume the motor efficiency. Motor efficiency how much? 90%. This is the motor. Motor. This is a belt. This is a belt. What is the belt efficiency? (98 ABC, 98%. Okay. What they asking? Find out the fan efficiency. This is very important. Find out the fan efficiency. Anyone know the fan efficiency formula? Always remember output by input. Okay, what is the output? Fan efficiency. . Fan efficiency. What is the formula? Fan efficiency. Simply you can write fan efficiency. Fan efficiency. Same output by input na into 100. This is a fan efficiency. So we have to find out what is the output, what is the input. What is the input? What is input? This is a fan input. Here is a fan shaft input. This is a fan shaft input. Always remember. This is a fan shaft input. Fan input equal to fan shaft. Okay, shaft power input. How to calculate shaft power input? Here, how to calculate shaft power input?
Motor efficiency into input power and belt efficiency also we need to calculate.
That is a shaft power input. So what you have to calculate first one? You have to calculate power input, motor power input. Then you can find out. This is one complete na input completed. How to calculate output? Output you have to calculate na. So what is output? Pressured air delivery na here air. What is output? Air flow. Air flow with pressure. Are you understand? Air flow with pressure. So how to calculate? Same formula you have to utilize. Same formula. Compare with input and output. Very important. So electrical. This electrical. So air for fan, pneumatic system. Fan. Output. What is input electrical quantity? What is input? P equal to VI cos phi. Clear? Same. What is the V? Pressure. V is a pressure. Same concept. Here V is a pressure. Pressure difference. V is a pressure difference. What is I here? What is I? Flow, air flow. Here is a current flow, here is a air flow. What is the unit? Air flow unit. Any idea? Meter cube per second. Then what is the cos phi? Power factor. Correction factor 1 divided by 102. Can you understand this one? Same concept. There is no difference. Only you have to understand what is the voltage. What as per the electrical voltage is a potential difference. Same as a fan airflow, pressure difference is a voltage. What is the airflow? Same like electrical current flow, electrons flow. Same here is a airflow. Same VI cos phi. Same you can write it now. You can write it. Pn equal to VI cos phi fan output power meter cube per second divided by 102. This is a pressure difference. This is a voltage. This is a current. This is for power factor, correction factor. Clear? Formula? Any doubt? Any doubt? Rahul, Hemnath, Aditya? Rajesh, Abul?
Okay, sir.
Pressure
E-
difference units will be kg
Same.
per centimeter square.
Yes. Here is a WW, is a mmWc. Once I write it, you can easily understand.
Okay.
Now, next, what is the calculation? Next is they asking fan efficiency. Fan efficiency. Fan efficiency means this input, this is output. For fan, this is input, this is output. This output now. This output, this is the input. So input, output divided by input. Say fan efficiency equal to so output divided by input. What is output? This is a fan output. Q meter cube per second. And what is the potential difference? You see, here is a 35. Here is a minus 25. So how much increase pressure difference? Minus 25 to 35 increase. Now understand why minus 25? So 25, it is going to minus 25, 24, then 0, then increase 35, up to 35. So total pressure difference, how much? Total pressure difference, how much?
$60.
Yes. So total pressure difference 60. So always remember higher minus 35 minus of how much? 25. The whole bracket. So divided by, it's a correction factor 102. Into what is the power input? Soft power input. Here is a soft power input now.
Motor efficiency into input power.
Yes. Motor
Multiplied with
efficiency,
belt.
belt transmission, that is everything. So we can, so soft power input. This is S sketch into 100. Now what are the data available now? So this is available. This is okay. So you have to focus on the simplest one. This is available. You have to calculate soft power. How to calculate soft power? Same you have to follow this one. So soft power equal to motor efficiency, belt efficiency into power input. So power input √3 into this one you have to multiply. So how much value? Soft motor efficiency 0.9. What is belt efficiency? 0.98. So √3. What is V? 410. What is the current? 19. What is the power factor? 0.8. Okay. Now tell me the value power input. Soft power input.
$9.52 kilowatt.
9.52 kilowatt. Okay, this is done now. 9.52 kilowatt. Next, what is the value? We have to find out. This is okay. You have to find out this one, na? Flow. Next, you have to calculate flow. How to calculate flow? Same like pump. There is no difference. You have to calculate flow. Same pump also we have done head difference, total differential head. Same like this, here is a pressure difference. There is no change. Only we have to add 102. There is a density available. Are you understand? Na?
Yes,
Common, always common point, always remember common. Not always no make it. Common, what is the common? All common. For electrical, mechanical, compressor, everything common. What is the common? Flow into potential difference. Pressure difference or potential difference, anything. Potential difference. Only correction factor change. Are you understand? Only correction factor change. What is the correction factor? For electrical? What is the correction factor for electrical? What is the correction factor for electrical? Any idea? Correction factor. Capacitor. Power factor, na? For electrical, power factor. For pump, which one?
density. No, sir.
Yes, density, gravity. For fan?
Is 102.
Yes, divided by 102. Simple. This is only you have to understand. Remaining flow potential difference common. So next question. Next, what you have to do? We have to find out flow. So flow, how to calculate flow? Hemnath, already you know, na, Hemnath. Flow.
Sir, சொல்லுங்க sir.
Yes, flow. How to calculate flow? Area into velocity. Area is a meter square. Velocity, meter per second. What is the area? What is the area? Here they given the area, na, 0.6 into 0.6 mm size. So multiply 0.6 into 0.6 and anemometer given 30 meter per second. Simple. So 0.6 into 0.6 into 38. So 35. So now tell me the value. What is the final value? Flow.
Yes, 10.8. Velocity is 30, no, sir?
30 or 35, sir? Sorry, 30. Sorry, sir.
It's 10.8.
10.8. What is the unit, sir?
It's meter cube per second.
Yes, sir. 10.8 meter cube per second. Everyone got this answer? Okay, next you apply in
Yes.
fan efficiency formula. Fan. You have to apply, what is the Q? 10.8. What is the potential difference? Always remember, finally you have to write it a unit. Very important. What is the differential heat? 35 minus of minus, how much? 70. Divided by?
16, sir.
Yes, sir, 60. Sorry, sir. 60. So 102 into 9.52 kilowatt. It's 100. What is the value? Just shift it from here to here. What is the value?
41.5.
41.5. Right? This is right? Check one more time.
Sorry, sir. 66.7, sir.
Yes, very, very important, Aditya.
Yes,
Carefully
I
you have to
would
do.
directly put this, sir.
What is the efficiency?
66.73.
Fan efficiency. 66.73.
73.
What is the main concept you have to understand? You draw the diagram, the fan, duct, motor. So they need fan efficiency. The fan efficiency, simple formula, this formula. So flow into potential pressure difference divided by 102 into fan shaft. This is a simple formula. This simple formula, what are the data we need to find out, very important. Pressure given na, easily. So which one is given easily? Pressure. So pressure difference done na? Any doubt? Pressure difference? Any doubt? Okay. Next one is a power input shaft. This how to calculate from the efficiency of this belt motor. This is also done. Next only you have to find out flow. So how to flow? Find out area into velocity. That is a flow. Just do it, is everything done. Sometimes the given the flow is in meter cube per hour. So meter cube per hour, how to calculate meter cube per second? Any idea?
Divided by 3600.
Yes, exactly. Okay. This calculus is clear, everyone? The diagram very important.
Yes.
Diagram very important. Duct, motor, fan, where is it coming? Belt, why they given? Belt driven efficiency, motor efficiency given. So you have to find out fan shaft. So they only asking about the fan efficiency only, not every efficiency. Also, you have to do it like this, calculus and everything. And you have to understand the electrical formula with hydraulic, with fan. Always remember flow into, what is the flow into? Potential difference. You have to understand power factor. So electrical 𝐂𝐴𝐳 is a very power factor. That means correction factor. Here also same, what is the correction factor? You have to understand. Remaining same formula. Any doubt in the formula? Same as a motor efficiency. Motor output divided by input, same like that, this one. Any doubt? Amul sir, Aditya, Rahul, Rajesh sir?
Yes, sir. Got it clear.
Okay, sir.
Yes,
Okay,
sir.
sir.
Yes, sir.
Okay, thank you, sir.
Sir,